Programming. We will start with Skyrora Technologies. Excited to hear what you guys have to offer.
Good afternoon, my name's Derek Harris and I'm here to talk to you about EcoScene by Skyrora. You're just about to watch my video presentation, which I hope you will enjoy, and I'm happy to answer any questions at the end. Thank you. Humankind is always stretched for the next technological milestone, and sometimes this can bring around life-changing advancements. We've moved from the steam engine through to mass production and currently the digital revolution. The mass production revolution has brought to us techniques to make items for consumers at a quicker rate. Though this has not always been a good thing, especially when it comes to plastics. Items that would normally be made of other materials have now been replaced by plastics, a cheaper solution to meet the needs of the consumer. Though with the abundance of ready-made material, we have created a much larger problem. Single-use plastics and landfill waste. You can see all around the world the waste produced by humankind in mass dump sites, and worst of all, our oceans. There are now more patches developing, like the Pacific Garbage Patch, which is twice the size of Texas than ever before. So how does this affect you and me and the people around the world? Well, we're poisoning our own environment and even our own food chain. As you can see, the marine life see floating plastics as potential food source, and it is now beginning to end up in our food chain. Here at Skyrora, we're always looking for new ways to make a greener and more ecologically friendly launch program. Skyrora held a competition to allow people to enter new ideas, aimed towards the core value of an environmental focus. The prize was a grant which was funded by the Skyrora CEO, Vladimir Levikin. Along with the funding was the opportunity to work with Skyrora's technical team to refine the idea with the aim of bringing the product and company to market. Thanks to this competition, EcoScene was born. EcoScene is a synthetic alternative fuel which is made from previously single-use plastic products. It could be polystyrene that protected your new television, or the wrap that goes around farmers' hay bales to keep them fresh for the winter months. Given a chance for these plastics to be given a second chance, rather than being banished to a landfill or to be incinerated. For every 1,000 kilograms of waste plastics processed, we are able to produce up to 600 kilograms of usable fuels. So let's take a look at the science of our process. Today, safe and complete recycling of many different types of waste quite rightly attracts a lot of attention from all over the world. That's why a new approach to waste proclamation is needed. Skyrora, the UK's leading launch vehicle company, has developed the equipment and technology to convert the waste hydrocarbon materials such as non-recyclable plastics, rubber, waste oils and sludge into a liquid fuel. The system is based on the well-known method of pyrolysis, with some of our own technological hardware improvements. The main advantage of our technology is the use of a natural catalyst which is readily available around the world. By using the catalyst, this helps to decrease the processing time and increase the output of the final product and allows for lower temperatures throughout the entire process. The product, which are processed in a mixture with the catalyst paste, are loaded into a detachable retort, which are mounted inside the furnaces. The simple interchangeable design of the retorts allow for them to be swapped out quickly and without any extra cost. The retort inside the furnace is heated up by the gases that are involved in the process of pyrolysis. The equipment also has a separate unit for collecting, compressing, storing and dispensing the produced gas through a burner. To simplify the production of the lightest fuels and commodity fractions in the manufacturing process, the setup has a fractionation chamber where liquid fractions are extracted. The resulting product is separated into two streams. The first stream is a heavy fraction which goes for recycling or as a heavy fuel oil. The second stream is a mixture of water, petroleum, diesel and gas. The second stream is fed into the arresters, which then separates gravitationally into the water, liquid hydrocarbon and gases. The production process is controlled from a single operational panel, where the temperature, pressure and other information at the control point is displayed, as well as the liquid level of each of the tanks. Some parameters can also be managed remotely. Coke ash from operation is easily removed from the retort once it is cooled, a process which can easily be mechanised. Natural resources are exhaustible, and more secondary are produced than can currently be reprocessed. The advantage of our system is that the synthetic fuels do not need to be extracted from primary exhaustible resources, such as minerals, oil and gas, but from secondary resources, even ones that cannot normally be recycled. Thanks to this tech, 100% of the input product is utilised, which increased commodity output. Its small size, modular design and simplicity of use allows it to be installed on waste collection sites, burial sites or even on a boat. The next step for Ecoscene is to certify our fuels and make any adaptations required for the aerospace and aviation industry, to help the industry as a whole become more environmentally friendly. The key to this project is the ability of Ecoscene to be refined and blended to be able to produce RP1 kerosene as well as Jet A1 fuel. As part of our market analysis, we took the most popular planes in the market being used by the aviation industry and found out that the average long-haul flight used 8.7 kilograms per kilometre of Jet A1 fuel. So imagine a single plane travelling from London to New York, which is a distance of 5,555 kilometres, is covered by burning over 48,000 kilograms of fuel. As of June 2020, the Defence Logistics Agency confirmed the price per gallon of Jet A1 fuel at $2.36. For Ecoscene to be economical and ecological, we would need to market the fuel around the $2.36 range. Skyrora has open conversations with the local authorities in Scotland over the waste plastic costs and current contracts. One of the local authorities, who are in early levels of discussion, is Fife Council, and they have confirmed their present method of plastic disposal is to filter out PET products and send the rest to landfill or incineration. This process has a sliding cost scale, depending on the types of plastics being disposed. For example, for 1 tonne of polystyrene waste, it would cost $114 per tonne. Alternatively, PVC would cost $160 per tonne to dispose of. This has allowed us to start negotiations for feedstock with local councils and companies, allowing for us to be paid to take the waste as well as process this into a product. The financial model will provide us a positive cash flow throughout the entire process. Our expectation is to agree a fee between $20 and $50 per mixed tonne of plastics. This fee will cover our costs of sorting to remove PVC from the delivered waste, as this plastic cannot be used in the process. Our analysis for production of Ecoscene, upon scale up from the demonstrator to a full-size plant, we estimate the cost of production of RP1 or Jet A1 fuels at around $1.50 per kilogram, leaving us in a competitive marketplace for selling a greener alternative fuel. To assist with the comparisons, we've used the assumption of weight for Jet A1 being 0.81 kilos to the equivalent of the US gallon. Ecoscene have already agreed an anchor client with Skyrora. Skyrora have used their rocket engines to qualify the RP1 and Jet A1 quality. Skyrora aim to launch 16 vehicles a year, as well as testing over 160 engines a year. As part of Ecoscene's development under the Skyrora branding, a deal has been confirmed to supply Ecoscene for these launches and tasks. We have entered into early discussions over licensing agreements with a progressive European country who's interested in the technology to help power all its internal flights. The fee is currently in discussion, but when signed would provide a guaranteed income to the company to allow for future expansions. The plans to bring Ecoscene to market has been delayed by the global pandemic, but it's not stopped the team pushing forward. We're currently in a grant process to cover the cost of the first full plant in Scotland with Zero Waste Scotland. Zero Waste Scotland is a national initiative to have no waste going to landfill by 2030. We have been entering Ecoscene into relevant awards and competitions to help prove out our business plan and pitch. As of September 2020, Skyrora and Ecoscene have been awarded the following: the Leif Erikson Lunar Award, Clean Tech Go Tech Awards, the Environmental Best Practice at the Green Apple Award, the Net Zero Energy Innovation Pitch Award, and Scotland Business Awards for the Innovation Award. Our environment is no longer just a character to be used in a Hollywood film. Around the world, thanks to the innovation of the digital age, we are more aware of the damage we cause to the Earth than ever before. The United Nations Sustainability Goals were established to provide a better future for the entire Earth. From affordable, cleaner energy to sustainable community. 17 goals to protect our environment. It would be easy to say we owe this to our children, to solve the messes that we've made, but it's still not enough. For real change, we need to roll up our sleeves and prepare to get dirty. I've brought Ecoscene here today for two reasons. The first, to highlight that plastics can play a part in a larger circular economy for the aviation and launch industry. Secondly, the United Nations Sustainable Development Goal number 17, Partnerships for the Goals. But I came here today to look for partners in line with the UN Sustainable Development Goals. It could be a company looking for a high quality fuel, or a sustainable investment fund manager looking for ways to invest, or even an airport who wants to follow those around the world that are now beginning to change their ways. I know Ecoscene can disrupt different sectors, from alternative fuel markets for aviation to space and beyond. The only limits are the ones that we will place in front of ourselves. NASA has always looked to lead the way, with some of the biggest and brightest ideas in trailblazing ways. It is no surprise that by hosting NASA's iTech Awards, it gives all the companies you have seen here today or will see the platform to make the correct partnerships. I thank you for your time today and would like to leave by asking you a question. What can you do today to make a change for tomorrow? My answer is Ecoscene. What will yours be?
Thank you so much. Ramona, let's open up the questions.
Yes, I understand that your first plant will be located in Scotland. How do you plan to approach other plants? Will you keep them under your company control, or will you franchise out, or what is that? I didn't quite catch all of that.
Hi there. Thank you, Ramona. Well, first of all, our intentions are we will look to have the plant with herself for the first one, but after that, we're looking at sort of license agreements, as it said in the video, with potential Northern European country. We're looking to license that technology to them to be able to use it.
What about for the rest of the world?
Yep, certainly the rest of the world is on there, and through some contacts I've met on NASA iTech and some other discussions, we have got a few discussions ongoing for some areas in America as well as Asia.
Thank you.
All right, John, you had a question?
Yeah, Derek, hey, thanks for the presentation. Great technology. Can you talk more about the space application through Skyrora, specifically to what orbits are they aiming and how much mass, and then anything else you'd like to add to that?
Yeah, certainly. So Skyrora are aiming to go to the polar orbits and sun synchronous orbits, and they can take up to 315, that's 315 kilograms per launch. The good thing about it is our top stage can start and stop in the vacuum, which allows us to deliver small sats and CubeSats to their designated areas before sending it back to burn up on re-entry.
Thank you.
Can you describe your IP portfolio? What do you have to protect this technologies?
Yeah, certainly with that, at this present moment in time, part of the system is general to market use, which has been seen by and can be used, so the pyrolysis side of things. There are a small portfolio which are currently with our legal team being reviewed before being put forward for patents on this, and we expect that to happen in the sort of next 6 months.
And with the mix of plastics that you use as the raw materials, how do you control the contaminants in there? I mean, do you have trouble with that, or is it straightforward in your pyrolysis approach?
With that, there is a little bit of a technique to that, which is something that I can answer off screen rather than on screen for this one.
Okay, but you have ways of removing things like sulfur and stuff like that? Okay.
Yes, there's ways to make it more sort of pure.
Thank you.
Hey, Derek, Jim Young. Interesting presentation. Appreciate it. Just a quick question. Can you share any insight on just the financial picture of the company currently?
Yeah, certainly with that. So at present moment in time, it is funded alongside Skyrora with that. So what we're looking at is raising funding through the Zero Waste Scotland, which will be somewhere between 200 and 600,000, which will allow for the very first batch or plant to be opened in Scotland. At this point, we believe that we can make it smaller if it's required to, or make it larger, and depending on which sort of way we go. So if we go for smaller to make it compact for boats, for example, going out to the Pacific trash patches, it'll be a much smaller amount of capex needed for that. Whereas if we want to make it go bigger, which I think we will do on some central parts, so for example, with the spaceports coming to Scotland, we'll want a larger one near there. It would require just a little bit more, so double that maybe. But we are looking to find ways that we can reduce that down as well in cost purposes.
Thank you.
Derek, this is Dallas Bainhoff. How are you?
I'm good, Dallas, and yourself?
Great. Have you thought about becoming an engine manufacturer for larger engines so you can sell engines to other rocket companies along with your fuel to expand your business that way?
Yeah, certainly. Skyrora has got a lot of things that have spun out of its R&D process between 3D printing, EcoScene, which brought us here today, and basically engines is another one, 3D printing the engines. So it is something that is on the cards and currently being looked at.
Can you say something about the production capacity of your Scotland plant, what you predict that it's going to be? And is that enough that you can run, that you would supply the fuel for a whole airport?
Yeah, certainly with that, it would depend upon the airports in Scotland. And at the moment, trying to get a full figure from the airports has obviously changed due to the pandemic. But what we anticipate, we would need maybe about 3 times the size of the demonstrator we have to run one airport for up to a month in that regard. So we're looking at Edinburgh Airport when we're discussing that. But the fuel intake, it would need to be running 24/7 and be 3 times the size of the demonstrator.
Hey, Derek, this is Ben Lockman. What's your power requirement for input power to the system? Is it do you use external power, or is it powered through feedstock?
With that, there's very minimal power coming from external with that. So the feedstock does provide the way for heating the pyrolysis and such. So most of it is taking off the actual feedstock going in. So for every 1,000 kilograms of waste that goes in, about 600 kilograms of fuel comes out. So 400 is used for sort of powering the whole process along.
All right, Sherman, you have a question?
Yes. How are you doing? My name is Sherman Williams. My question is, what is the environmental impact caused by your recycling process? Just want to make sure the juice is worth the squeeze.
No, that's a very good question. So certainly with that, when the processes go through, none of the gases are released. So normally if you were to bury the plastics or burn them, most of it will be sequestered into the ground, so it won't escape that way. With our process, because we use all the gases in the process, it means that they're not being released out into the environment. At the end of it, the actual fuel that comes out of it has a lower content of sulfur and other sort of contaminants, you could say, than the normal kerosene or jet A1 would have.
Got it. And then how much money has your company raised thus far?
Sorry, Sherman, you broke up there.
How much money has your company raised thus far?
So far with this, the money spent on this are invested into it is in the range of about 750,000 pounds. So, and I think in US dollars, that's about 900,000.
All right. Any other questions?
Derek, This is Kurt Sackstetter. I think excellent presentation, very interesting. I think that, one concern that you would eventually have would be ways to scale up your production to, larger and larger volumes and find economic savings according to that scale. But I'm interested in your thoughts on scaling this down to a small scale and the recoverability of the catalyst. And my intention there is to think about, could this be adapted to recycling waste in space where there is a lot of organic material that could be recycled into fuel in that application. So I don't know if you've thought about scaling in the reduced direction.
Yeah, so we have looked to see how far we can reduce it. So far, I won't say we've concentrated directly on space for sort of going to the moon, but we've been looking for the ocean plastic side of things. But once we get it to that, we believe we can still get it smaller, and it'll just be obviously the outputs that will be affected by the main size of it. The catalyst, which is organic material with that, hopefully that could be taken up with a vehicle and used in space. It's nothing that would be dangerous to carry.
So 2 questions related to that. Does your catalyst get recycled, and what do you do with the coke ash that you showed in your video?
Okay, so with the coke ash at the moment, it can be used for various applications, so heating and such. At this present moment in time, what we have been using it for is on some furnaces that we have for our other equipment, and just using that to sort of start the heating process up with that. What we do see going forward is that sort of coke and product is still used in the UK as heating for some places. So it'd be looked at as a secondary product that could be sold on the market.
And Cheryl, you have a question?
Cheryl, you're muted.
You can't hear me?
We can hear you now.
How about now? Okay. So it's clear from the website, Skyrora does a lot of other kinds of businesses. Is this technology going to stay in the parent company, or are you looking at spinning it off, or how are you going to kind of manage the two?
At present, we're looking to have EcoScene move on to become its own entity out with the company. It'll probably be like an umbrella corporation. So it will sit below Skyrora as the branding, but be run as its own company.
Thank you.
Can you say something about your competition? What other approaches are people approaching to do this?
Certainly, I don't want to say there's no competition. I just don't think the competition has pushed in the same direction that we have. I am fully aware that there are other people taking plastics and rubber to fuels, but these are mostly low quality fuels. I've yet to come across anyone that's aiming towards fuel grade aviation or rocket fuel.
Do we have time for another question or two?
We do. Go ahead.
George answer. Robin?
We have time for some more questions.
So Derek, I'm more interested in the propellant from an end user standpoint, especially for like small satellites or other satellites. Are there any performance advantages or disadvantages the use of this fuel for smaller scale propulsion systems? Are there any handling advantages or greenness that the full supply chain and process for the small satellites ecosystem would be favorable about or be concerned about?
Yeah, certainly with that. So it's, as I said, at the moment, we're talking with a few satellite companies as well about taking this on board. And that is ranging from their own onboard propulsion. And some of them are actually speaking about asking us to supply EcoScene for other vehicles, other launch vehicles that they launch on. And this is all to do with the new sort of green revolution that is being pushed along quite heavily within the new space market in the UK. So there is a big push for that purpose. But with it coming out as being potentially cheaper than alternatives that are available, a greener possibility, and if they're using similar to ourselves, Skyrora, which uses hydrogen peroxide and kerosene-based fuel for launches, it's, instead of burning off many different toxins, breaks down to water, carbon monoxide, carbon dioxide. And for a launch of our main vehicle, it works out about the same as a SUV in a week.
Okay. Because it's clearly the amount of propulsion, the amount of fuel used for these small sats is tiny. The cost savings aren't being realized there. But if we realize savings because the greenness of it and the handling of it, and the lack of toxicity, that's where it'd be really attracted to my teams.
There is one thing we have had with recent checks with that, which we've had some feedback that it's got an extra bit of a kick to it compared to the normal kerosene, for example, or normal RP1. But because this is only the first couple of tests from the demonstration plant, I don't want to come out and say it's got 5% better kit to it or something like that. But it's something we have noticed on the tests we've done ourselves and hope to be able to publish in a paper or something in the near future.
Terrific. Great presentation.
Congratulations to the whole, to all the participants and especially to the winners. Before we head out, I want to just give a big thank you to the NIA team. You guys have done a great job. This was my first event, and between the interactions that we had with the companies, but also all of the facilitating that's been done, all of the work and the coaching, and quite frankly, you guys holding my hand through this as I learned it too. I really appreciate all of you guys. And this was a great experience for me, and I think it's been a great experience for everybody. So thank you guys. I want to make sure that anybody who's watching the live stream right now, that you guys are aware that we have our Cycle 2 event coming up on October 15th and 16th. So please join us for that, where we will have another round of 10 companies showing us how their dual-use technology can benefit NASA. while still stimulating commercial markets. Thank you.